So, welcome to this lecture. In the last lecture, we will we have discussed the examples on permutations with repetition is allowed and the permutations with not repetition is allowed. Yes, so we have solved many examples on the concept of permutations with repetition is allowed. Now today we learn here the circular permutation. Yes, so first we see here what is meant by circular permutation. So circular permutation means, before that we will see here one example. It is left as an exercise for you. The example is, how many ways can we arrange the letters of the word appear? How many ways can the word start and ends with the letter P? The third one is, how many words can be formed by arranging the vowels and consonant alternatively? So here the word is given appear. In that word appear, there are 6 letters are there. Among these 6 letters, the letter P is repeated or occurs twice. After that, the letter A is also appears twice. Yes. So the question is, we have to find the arrangement of these letters of the appear word, or we have to find, it means that we have to find the permutations of these letters. So let us see. It is left as an exercise for you. You can solve it at home. Now come to the next point. It is a circular permutation. So here in a circular permutation, we have considered the permutation by arranging the elements in a line way. Yes, it is called as a linear permutations. After that, elements can be arranged in a circular manner, means in a circular ring. Yes, it is known as a circular permutations. So there are 2 types of circular permutations, which are depending on the whether the orientation or mirrored image arrangement are considered identical. So what are those 2 types? The first type is the circular permutation without reflection, and the second one is the circular permutation with reflection. So see, this is the figure for a circular permutation. Here the figure 1, the orientation is A, B, C, D. Yes, so this is the clockwise orientation A, B, C, D. In the figures second, it is A, D, B, C. Just you can move that one. After that, A, C, D, B. Yes, A, C, D, B. Here in the figure 4, A, D, C, B. In figure 5, A, C, B, D. And in the last figure, it is A, B, D, C. So from these figures, we can illustrate the example of arranging these 4 different elements A, B, C and D on a circular ring. Yes. So the question is, we have to find the total number of distinct circular permutations. Yes, by fixing the position of one element at the top of the ring. Already we have discussed here, shown here. Let us see, A is placed in the top of that ring. Yes, and all other elements are arranged relative to the fixed elements as shown in that figure. Is in the that A is positioned on top of that ring, and other elements are relative to that fixed element. Yes, so this is the procedure. So the first kind of circular permutation is circular permutation with without reflection. So the circular permutation are derived from that linear permutation. So there are 6 permutations are given in that figure: A, B, C, D, A, D, B, C, A, C, D, B, A, D, C, B, A, C, B, D and A, B, D, C. So these demonstrate that each circular permutation of 4 letters corresponding to 4 different linear permutations. Therefore, to find the number of circular permutations, we have to divide the total number of linear permutations by the number of elements. Yes, and hence the number of circular permutations without reflection is given by, we can consider the 4 letters A, B, C, D. That's why it is a 4 factorial divided by 4 circular permutations. Linear permutations we can divide it. We get the total number of circular permutations is 3 factorial. Yes. So let us see, therefore, the number of circular permutations without reflection is 3 factorial. So this concept can be extended for n elements. So how we can expand it? For n elements, there are n factorial linear permutations. Therefore, the number of circular permutations of n elements is given by the same thing. Total number of permutations of that elements is n factorial divided by total number of linear permutations we can divide, it is n, is equals to, if we calculate it, we get n minus 1 factorial. Yes. Now see the second case. It is the case of circular permutation with reflection. So in this case, we have considered the mirror images to be identical. So for example, in figure 1.1 to 1.6, means the previous figures, the permutation A, B, C, D and its reflection, means if we join these two figures, that reflection is there, that figures are identical if we join these figures. Similarly, the reflection of ABCD is ACBD. Hence, the total number of circular permutation with reflection is given by 4 factorial divided by identical element is twice, that's why it's 2 into 4, which is equals to 3 factorial by 2, it is 3. So I think, are you understand what is the difference between circular permutation without reflection and circular permutation with reflection? So for n elements, we can expand this result, we get n factorial divided by 2n, which is equals to n minus 1 factorial divided by 2. Yes. So these are the two cases. So let us see here the example 1 on this one. In how many distinct ways can 4 men and 4 women be seated around a circular table such that no 2 men are sitting next to each other? Yes, I repeat again, we have to find the total number of circular permutations with distinct ways. The 4 men and 4 women we have to sit around the circular table, and the condition is no 2 men are sitting next to each other. Yes. So see how we can solve this one. The arrangement is circular. Yes. So first we can arrange 4 women. So to remove that rotational symmetry, we can fix the position of 1 woman at the top. Yes. So this leaves us a 3 factorial base because there are 4 women. So therefore, the number of ways to arrange these 4 women is 3 factorial. Next, we have to place the men seated between the women. Yes, where the men can be placed. Since no 2 men can sit next to each other, that condition is satisfied here. If you place that men in between the 2 women. Yes, therefore, the number of ways to seat the men in between the women is 4 factorial. Hence, the total distinct arrangement where no 2 men are seated next to each other is 3 factorial into 4 factorial. If we calculate this factorial, we get 144 ways you can seat 4 women and 4 men where the no 2 women are seated next to each other. Yes, so these are the circular permutations. Let us see here now the second example. There are 7 members of council, including a president, a vice president and treasurer. So they need to seated at a round table, and the vice president and the treasurer must sit on each side of the president. So find the total number of possible sitting arrangement. So if you observe this example, there are 7 members of a council, but there is a fixed position of vice president and treasurer. It is either side of that president. Yes. So this is the movement, and we have to find the circular permutation. So let us see here the solution. As the sitting on a round table, we can fix the position of that president. After that, vice president and treasurer, both these two are seated either side of that president. Yes, either of left side or either of right side. So that arrangement is of 2 factorial because we have to sit the 2 position One is a vice president and another is a treasurer of either side of that president. Yes. After that, by fixing the president position and sitting the vice president and treasurer, we have 4 members, because already 3 members are seated: president and vice president and treasurer. The remaining 4 members we have to seat. Yes. How many ways? These are 4 factorial ways. And now you can total number of arrangement of 7 council members at the round table is given by 2 factorial, because these 2 factorial means treasurer and vice president are seated either side of president. One position is fixed, that is president, and the remaining 4 members you can arrange in a 4 factorial ways, which is equals to, there are 48 ways we can arrange this position. Yes. Now let us see here. Next example. How many distinct ways can 6 donuts be arranged on a circular tray such that the rotation and reflection of the arrangement are treated as identical? So read carefully again. So we pause here. You can read it. Yes, we have to arrange 6 donuts in a circular way, and the rotation and reflection we have to arrange as a treated as a identical. Means this is the problem of permutation, circular permutation of, yes, with reflection. So let us see. Consider the 6 donuts. We can label it as A, B, C, D, E and F. We have to arrange these on circular way. So to eliminate the rotational symmetry, we fix one donut as A in a specific position. Then you can reduce the problem to arranging the remaining 5 donuts around the fixed donut A. So remaining 5 donuts we can arrange in a 5 factorial ways. So after that, we arrange these 5 donuts in a linear sequence. However, since the reflection or a mirror image are considered to be identical to the original arrangement, so we must divide the total number of linear arrangement by 2. Yes, are you got my point? Why we can divide by it is 2? Yes, there are 6 donuts are there. Out of these 6, one position we can fix. After that, 5 factorial, there are linear permutations we can calculate of remaining 6 donuts. It is a 5 factorial way. But to overcount that reflection of that mirror images, that's why we can divide it by total number of divide by linear arrangement is 2. So thus the total number of distinct ways to arrange that 6 donuts on a circular tray under the condition the both rotation and reflection are not distinct, hence it is equals to 60. Now let us see here. Just I will show you here this example, and this is for your exercise. Read carefully. A florist has 5 different types of flowers: rose, lily, tulip, daisy and orchid. She wants to arrange these flowers in a circular way. How many distinct arrangements can she create? If arrangement that can be obtained by rotating or reflecting the where are considered to be identical. Yes, so this example is for your exercise. Just I will show you here the solution. You can calculate it. First you can say these are the fixed one flower, and then you can arrange the remaining 4 flowers around the fixed position in a 4 factorial way. After that, you can divide the number of linear arrangement by 2, and we get the identical elements are removed. So this is the final answer. Yes. So in this lecture, we have learned what is meant by a circular permutation. After that, we have discussed the 2 cases of circular permutation. One is the permutation without reflection, and another is the permutation with reflection. And also we have solved I think 3 to 4 examples here on circular permutations. Yes. So today we will stop here. Thank you.